Welcome to our deep dive into mastering data versioning with DVC. Today, we'll uncover how to manage, track, and collaborate on large datasets efficiently, ensuring your machine learning projects are consistent and reproducible.
Data versioning is often the unsung hero of successful machine learning projects. Without proper versioning, keeping track of changes, maintaining consistency, and ensuring reproducibility can become daunting tasks. Imagine collaborating with a team, only to realize that everyone is working on different versions of the same dataset. This is where DVC, or data version control, comes into play. DVC is designed to manage large datasets effectively, providing a seamless workflow for data versioning, much like Git does for code. In this video, we'll explore the steps to implement DVC, ensuring your data is always in sync and your projects are reproducible. Getting started with DVC is simpler than you might think. Begin by installing DVC using pip with the command pip install DVC. Once installed, navigate to your project directory and initialize a new DVC repository using DVC init. This sets up the required configuration files and directories. Next, you'll need to configure remote storage to keep your data backed up and accessible. DVC supports a variety of storage backends, such as Amazon S3, Google Drive, and more. Use DVC remote add remote_URL greater than to link your project to a storage solution. With these steps, your project is ready to start versioning data efficiently.
Versioning large datasets can be resource intensive, but DVC simplifies this process. Start by using the DVC add dataset_path command to track your dataset. This creates a .dvc file that stores metadata about the dataset, allowing you to version it without duplicating the actual data. When changes are made to your dataset, use DVC commit to update the snapshot in your DVC repository. This ensures that all changes are tracked efficiently, and you can revert to previous versions as needed. The power of DVC lies in its ability to handle large files seamlessly, ensuring your workflows remain smooth and efficient.
DVC not only tracks datasets but also manages metadata and dependencies crucial to your project. The dvc.yaml file plays a pivotal role here, allowing you to define stages of your pipeline, specify dependencies, and automate data processing tasks. By capturing dependencies, you ensure that your entire workflow is reproducible. For instance, if your dataset or script changes, DVC identifies the affected stages and allows you to update them efficiently. This management of metadata and dependencies ensures that your project remains organized and that each team member can understand the workflow without ambiguity.
Collaboration is at the heart of data science, and DVC makes it seamless. By sharing datasets and models through DVC remotes, teams can work on the same project without conflicting changes. Remotes act as a centralized storage where all data versions are stored and accessed by team members. Use DVC push and DVC pull commands to sync changes with the remote storage. This ensures that everyone is using the most up-to-date versions of datasets and models, fostering a collaborative environment. Additionally, DVC's version control capabilities mean that team members can experiment with different versions, sharing insights and improvements efficiently. Integrating DVC with Git creates a powerful synergy for managing both code and data. This integration allows you to track code changes and dataset versions in tandem, ensuring that they are always in sync. Use Git to version control your scripts and configuration files, and DVC for datasets. Commands like git add, git commit, and git push are used alongside DVC add and DVC push, creating a seamless workflow. This combination simplifies the management of machine learning projects, enhancing reproducibility and collaboration. By leveraging both tools, you ensure that your project remains robust and well organized.
Even with a powerful tool like DVC, issues can arise that may disrupt your workflow. Common problems include synchronization errors, conflicts in dataset versions, and issues with remote storage connectivity. To resolve synchronization problems, ensure your local and remote repositories are in sync by using DVC pull and DVC push. If conflicts occur, assess the changes in the .dvc files to identify and resolve discrepancies. DVC provides logs and status checks that can be valuable in troubleshooting. Use DVC status to identify files that need attention and DVC doctor for diagnosing potential issues. By proactively addressing these challenges, you maintain the integrity and efficiency of your data versioning process. To maximize the benefits of DVC, adhere to best practices in data management. Begin by organizing datasets into logical structures that align with your project's objectives. Regularly commit changes using DVC commit to keep track of your progress and ensure reproducibility. Utilize remote storage efficiently to back up important data and facilitate collaboration among team members. Documenting your workflows, including the use of dvc.yaml and other configuration files, provides clarity and guidance to all project contributors. Lastly, consider integrating DVC with continuous integration tools to automate testing and deployment processes, further enhancing your project's efficiency and reliability.
As we conclude this comprehensive guide on data versioning with DVC, it's clear that mastering this tool can significantly enhance the efficiency and reproducibility of your projects. By implementing the practices discussed, you'll ensure that your datasets are well managed, your workflows are seamless, and your collaborations are fruitful. We encourage you to apply these strategies in your projects and share your experiences in the comments. Let us know if there are other topics you'd like us to cover in future videos. Don't forget to like, share, and subscribe for more insights into data management and machine learning.